Let's see how we could extend this CPU from an 8-bit to a 16-bit. If you get into the resources section, you'll see there's a file called CPU_design_bonus_16-bit. So you can open it up and you head down to CPU test and double click that. And what I've done is I've extended the 8-bit CPU that we've just designed to 16 bits. So we've now got a 16-bit bus running around the outside. All the registers now are 16 bits. So you can see there's now 16-bit registers here. And if we head in, you'll see that whenever we get into the ALU, all the functions within the ALU have now got 16 bits. So if I was to head into the control section, now I've left the control section as it was previously, but there is a certain difference now, is that we now have 16 bits coming in to the control section. So this is 16 bits coming in here as opposed to the 8 bits. So that means that we're going to have available to us an extra 8 bits in order to define what happens within the control section. So you could envisage coming here, instead of having a 3x8 decoder and having 8 different functions that we can perform here, you could have the extra 8 bits and you could have a whole load more functions that you could perform. Now that would allow us to increase the number of instructions in our instruction set, and in fact if we were to look at an actual modern CPU, the instruction set would be much bigger than the one that we have created. But you can see here that there is a potential of extending this design in this manner. But if you were to try and actually run this as a 16-bit, you'll find that you would run into problems. It would just run very, very slowly indeed. So we've really reached the limitations of using our Logisim by building an 8-bit machine. But we've seen earlier, whenever we designed the debugger, that we have an alternative process of simulating our CPU. So we could write it in, for example, VBA, or we could write it in any other program language, Java, C, C++, and we could model the CPU. As long as we understood and were able to define our instruction set, then it's perfectly feasible for us to model our CPU in one of those languages, as opposed to building it in this physical sense here in Logisim. So there are lots of different ways that we can take this simple CPU and extend it and expand it. We can look at increasing the instruction set and having more complicated instructions. We could also look at creating a simulation or a model of the CPU, an extended model within a programming language of your choice. We could also look at actually trying to realize this CPU using physical components. Another option is that we could design the CPU in an integrated circuit format. So there are lots of different ways we can extend on this course. Another option would be to try and write a higher level programming language, something quite simple, but something with the basic constructs that you would recognize in looping structures, for example, the for, next, do, the while, the if, then and else statements. And then writing for that a little parser that will allow us to change it from the programming language that we have down into the assembly language, and then we could use our assembler to get it into the machine code. So keep an eye on the resources section for extra programs. Also, if you have any assembly language code you like to try and write, or you're having problems with, you can always get in contact with me. Something else we could possibly do as well is build up a small set of routines that we would tend to use quite regularly. For example, the multiplication routine, we could have a division and a subtraction and so on and so forth. And from those little routines you could build up a simple little code or a simple little method of employing those routines efficiently onto the CPU. So hopefully that's given you a few ideas and a taste for what will come in future courses. Thank you for listening to this video. Goodbye.